Let's do it. All right. Market researchers suspect that background music may affect the mood and buying behavior of customers. One study in a supermarket compared 3 randomly assigned treatments. Under each condition, the researchers recorded the numbers of bottles of French, Italian, and other wine purchased. Here's a table that summarizes the data. So the difference between last week and this week is that last week we were looking at if there was any difference in the distribution of a single variable that we were measuring. Now, these chi-square tests are going to talk about the way that we can compare 2 different categorical variables and look at the relationship that they have with each other. So let's look at part A here. We're going to calculate the conditional distributions of the type of wine sold for each treatment. Then we're going to make a graph. I'm going to be making a bar chart. And then based on those graphs, see what differences there are. And eventually we're going to see if those differences are statistically significant. So let's take a look at how this breaks down here. So we have our music that we are listening to here, and we are looking at when the music changes within each different type of music, what are the buying habits. So that is what we are going to be looking at and doing. So first, there's our table. For example, I'm going to show you this one, and I'm going to give you a minute and see if you can come up with the other conditional distributions. When there was no music playing, the distribution of wine purchases was that there were 84 people in the no music group. Then the distribution was the proportion that bought the French wine was 30 out of the 84 that got no music. The Italian was the 11 out of the 84 that got no music. And other was 43 out of the 84 that got no music. And there's the proportions. These 3 proportions should all add up to 1, or 84 out of 84. So there are my 3 proportions. That is in the no music category. So I'm going to give you a minute, and I want you to do the same thing for the French music category and the Italian music category. And then what you're going to see is that we're going to make a bar chart, and we're going to compare what differences there are between these 3 distributions. And overall, what we're looking at is, does the type of music playing have any kind of effect on the product that is getting purchased? I'll give about another minute. You might want a calculator so you can get the decimals out. right, hopefully, this is what you got. When the French music was playing, here were the buying habits. When the Italian music was playing, here were the buying habits. Just to give you a broad picture here while you're writing those down, this section is going to have two different chi-square tests in it. The difference between them is going to be what we're going to say for the null and alternative hypothesis. But everything else is going to be the same. The conditions are going to be exactly the same. The formula is going to be the same. The place we go to on the calculator to get it is going to be the same. All of that is going to be the same. Conditions are going to be the same. The way we get degrees of freedom is going to be the same. The only difference is how the null and alternative hypothesis is phrased. And so today, my overall plan is we're going to spend the day setting up the formulas and the work and and where to go in the calculator and all that. And then tomorrow we're going to look at one of the chi-square tests. And then Wednesday we're going to do some FRQs. Thursday we're going to look at the other chi-square test and do an example or two with that. Friday at our Zoom, we're going to go over the set of FRQs that is due on Friday that I handed out last week. Monday review, Tuesday test. 11:30. So here it is in the bar chart. So there might be a prediction that you can that you might have been able to predict. Notice that when the music was French, look at what happened to the Italian buying purchases and the French-Italian purchases. This went quite a bit down. This went quite a bit up. And then when the Italian music was playing, this went quite a bit up. This went back down to where it was. The question we're going to ask with the chi-square test is, are these differences in the buying habits statistically significant? In other words, would they lead us to reject the null in favor of the alternative that playing the music actually makes a difference in the buying habits? So right now we can make some observations in comparing the three different categories. Anytime it asks you to compare, you might want to write some stuff about, that means it probably wants you to point out some things that are similar between the different categories and some things that are different between the categories. All right, there, and there. All right. And now presenting a bunch of things that I'm going to come back to later. Moving on. Finding Expected counts is not that difficult, as the following example illustrates. Thanks, textbook. Good to know it's not difficult. All right. So, here's what we are testing for. We are testing for, is there any difference in the buying habits between these three? So, just look back at the table for now. Looking back at the table, it it'll turn into something else that is a slide in your notes. Okay. So, if there is no difference between the buying habits, then what should happen is that the amount of people that buy the French wine should be pretty much the same across all three categories. Well, how many of them bought the French wine? Well, that's going to be 99 out of the 243. That's how many in total, or what proportion in total bought the French wine. And that is what? Someone give me decimal. Should be like 0.407, okay? And that percentage, that proportion, should stay the same across all three categories. So about 40% of this group should be buying the French wine, 40% of this group should be buying the French wine, and 40% of this group should be buying the French wine. So how many are in each group? So this is across, this is getting the expected counts for these three values. The expected counts for these three values should be that percentage of everyone in the no music category. That is 84. And then for the French music category, I would expect that percentage, that about 40% of the 75 people in the French music category. And then over here, I would expect about 40% of the people in the Italian music category. That is 84 again. And that would give me the expected number of people that would be listening to each of the types of music. Now, here's parts in your notes. So there's the 0.407. So that percentage of each of them. And then we can do the same thing for the Italian. 31 out of the 243. So that percentage of each category should get the Italian wine. That percentage of each of the different types of music should get the Italian wine. And then 113 out of 243, that percentage of each of the different types of music should get a different type of wine. So there are all the expected counts. So that's these three. And then here's the work shown out for all the rest of them. Okay, that is in your notes, correct? And already written down. All right. Moving forward then. So the way that that formula comes about, notice what is on each of these, what is on the numerator and denominator of these fractions. So let's take this first count. So instead of the proportion, let's put the fraction back in and look at what numbers are on top and what numbers are on the bottom. Well, the number that's on the bottom is the total of the entire table. The grand total of everything on the entire table. And what's on the top is my total, what went on the top of the fraction was the total across the row. And then what went here was the total down the column. And so that goes on top of the fraction. So the way that I get the expected counts here, the way that that formula is going to work, ready for more fancy PowerPoint animations here. Oh, wait. There they go. So that's another way we can write. That's just rewriting it so that my totals for the rows and columns are on the top, and then the entire total is on the bottom, which will give me a formula for expected count. Row total times column total over grand total is usually how I'm going to say it, but the table total. And that's how we get expected counts. So there are two things here that you can kind of consider a formula that you'll have to memorize. One of them is this, and then the other one is how to get degrees of freedom, which we'll talk about in just a second. Other than that, there's almost nothing really all that new in this section. So if you want to double check that you understand how that formula works, you can use that row total times column total over grand total and make sure that you can get these expected counts correct. If you want to double check your work there. All right, row total times column total over grand total. Chi-square statistic. Oh, we're gonna have three conditions for checking before the chi-square statistic. Guess what they're gonna be? They're gonna be all the expected counts being at least 5, random, independent. It's gonna be the same three conditions that we've been using. And guess what the formula is gonna be for the chi-square statistic? It's gonna be the sum of observed minus expected squared over expected. So the sum is over all the cells, not including the totals, in the two-way table. So you should have gotten the expected counts there. So here is one table with the observed and one table with the expected. See if you can get the chi-square statistic. This is the one time that I'm going to have you write out the entire formula. I will not make you plug the entire formula into the calculator here. So you're going to write out each of the 9 things that you are adding together, if it's not already there. Some of them are already there. Write out the rest of them. And again, when we write them out in step 3, you're going to write out, there are 9 terms here. I'm not going to make you write out all 9 terms every time. So in the case of, in those cases, I want you to do what they do on the paper there, which is write out the first 2 terms and then put a dot, 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 and then write the last term. And I'm going to go ahead and double check you on one or two of these terms. So someone give me Italian and Italian. What's the chi-squared part of the formula? Yep, that's how it should look. Someone else give me none and other. None and other. Observe minus expected. Squared. That's when I've been looking across people's work and something's missing in their calculator or doing that. The biggest thing that they forget is they forget the squared. And then the calculator gives them the wrong answer, or the formula is not written right. And so, again, that formula of observed minus expected squared over expected is on your formula sheet. I want to mention it here. This is on your next slide, but I do want to mention it here. Degrees of freedom. Again, this will be on the next slide, and I'll circle where it is on the next slide. But I just want to mention it real quick so that you can know what it is here. Equals number of rows minus 1 times number of columns minus 1. Rows minus 1 times columns minus 1. That is not including the totals. That is just including the cells here. So the cells within here. So in this case, degrees of freedom would be there are 1, 2, 3 rows and 1, 2, 3 columns. So it would equal 2 times 2, which is 4. And you would have 4 degrees of freedom. Did you guys cover matrices? Yes? Do we know how?
Yeah, it was like the last unit before we got sent to the laptop.
You did it on the calculator?
It was literally
So if I said put this 3 by 3 matrix into your calculator in matrix A.
Nope. Not happening.
Okay, let's because that's how we're going to get this chi-squares test out of the calculator.
Oh, it's second matrix, right?
It is. There's a matrix key. That is the PowerPoint. That's not helpful.
No, I have a quick question.
Calculator.
Okay, never mind.
One second. Second. Matrix.
You could do this also on Desmos.
Probably, yes. So, remember, this is a key thing to remember about matrices. Do not use this menu until you go to Edit and enter the matrix in the calculator. It is 3 by 3 because there are 3 rows and 3 columns. Remember, rows first, then columns. So this is a 3 by 3 matrix. And then you would go ahead and enter this into matrix A. So go ahead and do that. While you're doing that, you had a question. Yes.
So this is kind of random, but during the AP stats test, I deleted my list one, and I don't know how to get it back. So can I ask you to show me how to do that after class?
Give me just a second.
Do I have to do the expected one too, or just the observed?
Nope. I just want the observed one. I just want to make sure you can do it. Okay. All right. We got a matrix looking like this.
Yes.
All right. Check it out. Stat. Tests. Chi-square test. Remember, chi-square goodness of fit test was last chapter, and we had the observed and expected in list 1 and list 2. Right? But chi-square test, observed, matrix A. We put our observed in matrix A. Expected, we're going to say matrix B.
I didn't put it in B. Why do I not have to put it in B? It did for me? I love the calculator so much. Oh my gosh, seriously?
So, for those of you that missed it, we tell it my observed counts are in matrix A. And I told it, put the expected counts in matrix B. So when you go to check the expected counts condition, you're going to go ahead and just put this matrix into step 2. Say, here's my expected counts. Hey, look, they're all at least 5. That's what you're going to put in step 2. You should still know how to calculate row total times column total over grand total. Degrees of freedom, it said was 4. It was 4 because number of rows minus 1 times the number of columns minus 1. And it gave you the chi-square statistic and the p-value with degrees of freedom of 4. That's geometry. All right. Any questions on that?